behind me is a key to the cleanest and most abundant fuel source on the planet. It's in the form of a mineral deposit rich in zinc, silver, copper, gold, and lead. Hi, I'm Jim Hawley, president of Blackstone Mining Company Limited, and today I'd like to introduce you to our subsidiary, Blackstone Hydrogen Energy, which, using a simple chemical reaction of zinc hydrolysis, can turn zinc ore into hydrogen fuel, where the exhaust is drinking water.
The company's focus is on our patent-pending technology for producing hydrogen fuel from the Blackstone's hydrogen-compatible zinc ore and recovering the copper, lead, silver, and gold as a byproduct of the hydrogen fuel production. The company's hydrogen fuel technology extends beyond the Blackstone in the form of off-site hydrogen production facilities, where Blackstone zinc powder is the cornerstone of manufacturing hydrogen in a simple zinc hydrolysis reaction, commonly known as water splitting. The byproduct of both the on- and off-site hydrogen production is zinc oxide, which can be thermally reduced back to zinc powder to repeat the hydrogen production cycle multiple times. One charge of Blackstone zinc powder can be used multiple times to produce more hydrogen. The economics of the company are quite compelling, given just the zinc, copper, lead, silver, and gold values of the hydrogen-compatible ore inventories at the Blackstone, before adding the income from hydrogen production. The gross value of the Blackstone hydrogen-compatible stockpiles, proven and probable reserves, exceeds $480 million at current commodities prices. For example, according to an independent valuation of the property, a ton of Blackstone hydrogen-compatible ore contains about 170 pounds of zinc, 100 pounds of copper, 80 pounds of lead, 23 ounces of silver, and a 10th ounce of gold. Based on recent commodity prices, that ton of ore has a value of about $1,980, assuming the zinc is marketed as zinc powder or zinc oxide. The Blackstone zinc ore to hydrogen processing cycle requires about 7 pounds of vaporized zinc to produce 1 kilogram of hydrogen, or about 24 kilograms per ton of ore. About 210 pounds of zinc oxide is also produced as a byproduct of the hydrogen reaction. Hydrogen has a market value of about $18 to $20 per kilogram delivered, thus adding about $440 of value to a ton of ore, increasing its gross value to over $2,400 per ton. Now consider the 200 plus pounds of zinc oxide produced from a 1-ton zinc hydrolysis reaction. If the zinc oxide were reused 10 times to manufacture more hydrogen, the gross value of the Blackstone ore would dramatically increase to over $6,000 per ton, raising the value of the stockpiled, proven, and probable hydrogen-compatible reserves to about $1.5 billion. A technical note: as previously shown, zinc oxide needs to be thermally dissociated back to zinc powder at temperatures above 1794 degrees centigrade to be reused in the hydrogen production process. Scientists in the US, Europe, and Israel have successfully built dissociation reactors with over 90% recovery of zinc powder from zinc oxide using concentrated sunlight. In contrast, the company will be using a solar-powered reactor, where the dissociation chamber contains an inert gas atmosphere, or biomass, which will reduce the required dissociation temperatures to a more manageable 1300 to 1500 degrees centigrade. This diagram illustrates the hydrogen processing cycle and the subsequent recovery of the copper, lead, silver, and gold values from the Blackstone's polymetallic ore. The company intends to install a pilot-size hydrogen manufacturing plant at the Blackstone to begin production of marketable green hydrogen and matte bullion. The plant will be green energy self-sufficient using a combination of solar and hydrogen power. While initially small in size, the processing plant will also be economically independent, resulting from the profits from the sale of hydrogen fuel, metals, metals oxides, and metals powders. Worldwide hydrogen production is about 57 million metric tons annually. The U.S. produces about 11 million metric tons per year, 95% from burning natural gas or other fossil fuel in a process called steam reformation. The remaining 5% is produced primarily from the electrolysis of water. Hydrogen produced by steam reformation, also known as brown hydrogen, costs about 3 times the price of natural gas per unit of energy produced. Hydrogen from electrolysis is about 1.5 times more expensive than using natural gas. Blackstone's zinc hydrolysis produces green hydrogen, and zinc oxide is a byproduct of the reaction. The zinc oxide is dissociated back to zinc powder using a solar-powered reactor to repeat the hydrogen production cycle multiple times, increasing the profitability by the number of times the zinc oxide is reused. In the case of steam reformation, the process emits carbon dioxide, a primary contributor to greenhouse gas, as opposed to Blackstone's zinc hydrolysis method, which is emissions-free. About 50% of hydrogen is used in the manufacture of fertilizer and ammonia, the balance in oil and gas refining, chemical, food, and metals industries. In the U.S., the sale of hydrogen is estimated at about $100 billion annually, at an average price of about $10 per kilogram, not including the delivery costs.
A little history. The Blackstone has been a periodic producer of copper, lead, zinc, silver, and gold from the surface ores and near-surface ores since its discovery in the late 1800s. The property got its name from the deep, dark, black veins of zinc that the prospectors encountered in their early workings. In fact, drilling in the pit area in the mid-1980s produced a series of cores that were deep, dark, black rock. Those cores assayed in excess of 25% zinc. My namesake and former Idaho Governor James Hawley patented the 100-acre Blackstone mine complex in 1903, resulting in the federal government vesting fee simple title and private property rights in the company. He and his partner, Justice Samuel Rich, expanded the underground workings by driving a cross-cut tunnel about 25 feet below outcrop level that intercepted a 6-foot wide vein reported to contain copper, lead, zinc, silver, and gold. 50 tons of that ore was shipped to a smelter in Salt Lake. At today's prices, that 50 tons of ore would be valued at about $100,000.
Surface development of the Blackstone in the 1980s dramatically expanded the 6-foot wide vein in the underground workings to a 110-foot wide mineralized zone. From the open pit workings on the east end of the property, the mineralized zone is visible at the surface, traversing the 100-acre complex for about 1.5 miles to the west. The company believes the concentration of zinc present in the Blackstone mineral deposit could supply its zinc-to-hydrogen technology needs for decades to come. While vast regions of the deposit remain unexplored, geological data from previous development work points to a massive zinc, lead, silver, copper, and to a lesser extent gold deposit. Of the geologists and mining engineers who have evaluated the Blackstone, including the United States Geological Survey, all agree the chemical composition and age of the mineralization confirm the polymetallic ore in the mineralized zone is an intrusion from the Idaho batholith, a huge granitic chamber about 1.25 miles below the property's current workings. If so, there could be literally hundreds of millions of tons of hydrogen-compatible ore in the Blackstone deposit. In a 1984 report, George Vasiloff, a well-known Idaho mining engineer, estimated an inferred block of 3 million tons of hydrogen-compatible ore in the first 100 feet of depth in the mineralized zone. In a 1996 report, Dr. Richard Kucera, fellow of the American and Canadian Geological Associations, calculated stockpiled, proven, and probable ore reserves equaling 250,000 tons, now identified as hydrogen-compatible ore, valued at $483 million at current commodities prices. Robert Bell, geologist, mining engineer, and Idaho State Inspector of Mines, published a study in 1930 where he compared the Volcano Mining District, home to the Blackstone complex, to the famed Butte, Montana Mining District, home to the richest hill on Earth, describing the two mineral deposits as having a, quote, blood relationship to one another, based on nearly identical topography, geology, and mineralization. Blackstone and Blackstone Hydrogen Energy, poised to make a significant contribution to green energy and alternative fuels, where our technologies have the potential to make a positive worldwide environmental impact in the reduction of greenhouse gases.